In this video, we will be looking at how to sketch the force diagram as well as the free body diagram. So looking at example number 1 on your left, so we have a box here that is on top of a table, and they want us to sketch the force diagram for this box. Okay, so whenever you are sketching a force diagram, you need to draw your object first, and you can just simplify things and just draw like a 2D box just to simplify things. You don't have to draw a 3D box. So this represents my box, and then from then you ask yourself this question. You say, what are the forces that are acting on this box as it is lying on top of the table? Okay, so now the forces that are acting on this box as it is lying on top of the table, we have gravity. That's the first force. So you draw it like this. As we know, gravity acts downwards. So this will be your Fg, or sometimes it can be written as W. And then we also have the normal force, which is the force that acts perpendicular to the surface of the object. And in this case, the surface of the object is that table, right? So the normal force will start here from the surface at the bottom, and then it will go up like that. Okay, and that is it for the force diagram for the scenario on your left. We are only having the forces that are acting on that box as it is lying on top of the table. We only have the weight as well as the normal force. Then for the free body diagram, whenever you're drawing a free body diagram, you represent the object as a dot. So you sketch the dot first, and then you put all the forces that are acting on the object. Again, we have the weight. So you put your weight first. We know weight acts downwards, or sometimes you can say W. And then you also have the normal force, which is the force that is acting perpendicular to the surface. Okay, so that is it. This is the force diagram for a box that is lying on the table, and this is the free body diagram. I hope you guys can see the difference between the two. With the force diagram, you draw the object, and to simplify things, you can just simply draw a 2D box. You don't have to draw a 3D box. You can just simplify things with just a 2D box. And then with the free body diagram, you represent the object as a dot. Moving on to the second example on your left. So if you check here in this example, we are having a person who is pushing a box. And we're going to assume that there is friction here. As this person is pushing this box, there is friction on the surface. Okay. Then now we need to sketch the force diagram first. Again, the force diagram for the box as this person is pushing it to the right. Again, I'm going to draw the box. To simplify things, I just draw it in 2D. Okay. Then we have an applied force. I hope you can see this person is pushing this box to the right. So we're having an applied force. So here is the applied force. And then we also have the normal force. Remember, normal force, it is the force that is acting perpendicular to the surface. So the surface of the box is here, down there. So you draw your normal force from the surface going up. Okay, so that's your normal force. And then also this box, remember, it has a weight, right? So it has weight. So we're going to have weight as well. And it is going to act downwards. So that's your Fg or W. And then this is your normal force. Okay. However, there's also another force that is acting on this block. As this person here is pushing this box to the right. Remember what I said? There is friction. And friction, it is a force that acts in opposite direction of the motion. Okay, so the object is moving to the right, and obviously friction will do what? Will move in opposite direction, which is to the left. So friction will act in the opposite direction, so it will move to the left. So we need to also put frictional force. Okay, and now moving on to free body diagram. Remember, with free body diagram, you represent the object as a dot, and then you put all the forces that are acting on the object. In this case, we have force diagram. Sorry for that. Force applied, rather. And then we have weight, which is your Fg, and then we have frictional force, and then lastly we have normal force. Okay. One thing which is very important, which I should mention, is I hope you guys can see that all my forces are going out of the object. Okay, so there's no force that is going into the object like that. Even with my applied force, I didn't apply my applied force like that, but instead I applied it like that. So you need to be careful as you draw your free body diagram. Ensure that your forces are going out of the object and they don't go into the object. Moving on to scenario number 3. So in this scenario, we are having a box again, and there's someone who is pulling the box to the left. Okay, so to sketch the force diagram, we're going to have this box here, and then we're going to have force applied. So this will be the force applied. So let us assume this person maybe is pulling this box at an angle of 30 degrees, right? So you'll put your 30 degrees here. And let us also assume that there is friction here. As this person is pulling the box, there is friction there. So we're going to have the force applied. And then we're going to have the weight of the object. So we're going to have the weight of the object, which is your Fg, and sometimes it can be W. And then we also have the normal force, which is the force that is acting perpendicular to the surface. So this is the normal force. And then lastly, we're also going to have friction. I want you guys to notice something. So this box, it is pulled to the left. And remember, friction, it is a force that acts in opposite direction of the motion. So what is going to happen here is that as this person is pulling this box to the left, the friction will go to the right in opposite direction. So the friction here will go to the right, frictional force. Then now to draw the free body diagram, remember we represent the object as a dot, and then we put all the forces that are acting on the object. And in this case, we are having weight, which is your Fg. We are having force applied, which is applied at an angle of 30 degrees. We also have normal force, and lastly we have frictional force. Okay, so these are the forces that are acting on the object. Moving on to another example. So basically what is happening here is that the object is sliding down the slope. So to sketch your force diagram, what I usually do, let me use a different color. I would sketch, and I'm going to erase this soon. I will sketch the slope. Let me go back to my black pen. So this is the slope. The one in red is the slope. And then I'm going to draw my box. Remember, this is the force diagram. I'm going to draw the box. Then after drawing the box, I will then sketch all the forces that are acting on the box. Okay. So again, as this box is sliding down the slope, we will assume that there is friction here on the slope. So let us assume there is friction. And another thing that is very important, if it happens in an exam, they say friction is neglected or ignore friction, then you won't include your frictional force as you draw your force diagram or your free body diagram. So now, to sketch all the forces that are acting on the box, let us see which forces are those. So we have weight, which is going to act downwards. So this is the weight of the box as it is sliding down. So we're going to have the weight, which is Fg. Then we're going to have normal force. Remember now, this is very important. This is the surface of the object. This is the surface of the object. And I hope you can see that this surface, it is at an inclined. Okay. And remember, what is normal force? Normal force, it is the force that acts perpendicular to the surface. So you need to ensure that as you draw your normal force, you draw it perpendicular to the surface. So it will be like this in this case. This is the normal force. And I hope you can see that this normal force, it is perpendicular to the surface. Okay, so you need to be careful as you draw your normal force there. And then another force that is acting here will be friction. Okay, so the object is sliding down the slope. And remember, friction is a force that opposes the motion of the object. So it acts in opposite direction. So now, as this object is sliding down, friction will act in the opposite direction. So it will act in this direction. So this would be the frictional force. And that is it. This is the force diagram for the box as it is sliding down the slope. Then I will then erase this surface that I drew here in red. Let me just erase it. Perfect. Because in an exam, you don't want to see this surface. I was just doing it so that I can be able to see my normal force. So now, moving on to the free body diagram now. Again, I'm going to sketch the surface at an angle, and then I'm going to sketch my dots. Remember, free body diagram, whenever you draw a free body diagram, you represent the object as a dot. Then, what are the forces that are acting on the object? We have weight. This is our weight, Fg, or you can say W. Then we have normal force, which acts perpendicular to the surface. So here is my normal force. I'm sketching it perpendicular to the surface. And then we also have frictional force, which is the force that opposes the motion of the object. Then from here, I'm going to erase this surface. Okay, and this is my free body diagram. Moving on to the last question. Now, what is happening here on the last question is that the box now, it is going up the slope. Okay, so it is going up the slope. And they want us to sketch the force diagram as well as the free body diagram. Again, I'll sketch the slope. So this is the slope. And then let me go back to my black pen. So you draw the box as it is. And then you ask yourself this question. What are some of the forces, or what are the forces that are acting on this block as it is going up the slope? So we are having weight, which is acting downwards. So we have Fg, which is your weight. We have normal force, which is acting perpendicular to the surface. And then remember, frictional force, again here we will assume that there is friction on the slope. So we'll assume there is friction on the slope. So now remember, frictional force opposes the motion of the object. So as this object is going up the slope like that, the frictional force will act in opposite direction. So this will be frictional force. Okay. Then on the free body diagram, we just sketch a dot. Okay, I forgot to erase the surface. I don't want to see that in an exam. I'm going to draw it again here, the surface. And then I start sketching my object as a dot because now I'm drawing my free body diagram. And then I'll have weight, which is acting downwards. And then I'll have my normal force, which is acting perpendicular to the surface. And then lastly, I will have my frictional force, which is acting in opposite direction of the motion. Okay. Then erase the surface. Great. So that is it for this video, guys. See you on my next video. Thank you.